Yeah, actually, you're pretty clipped over there. Well, you're fine. All right, my name is Benjamin Meads.
I'm Val Clark.
All right, so our initial project that we decided to do is a classic Pong game. As you guys know, Pong is made up of two paddles that are player controlled on either side and a ball that bounces between them. The general purpose is that if a ball gets past your paddle, the other player scores a point, or if you hit it, it bounces back to the other side. We set out to make this game using our microcontroller, along with two LCDs, a LED matrix, and then 4 buttons to be able to control it. So the buttons will either move up and down your paddle along the LED or LCD screen, and then the LED matrix. We originally decided to do 8x8, but we switched it over to be 8x32. So now it just kind of bounces between it. We did change a couple of the things along the way, such as, like I said, switching an 8x8 array to a 8x32 array. This gives the ball a lot more time to travel to the other side, and it gives one of the players a little bit more time to react to how it's going to be going. We originally were going to have a third LCD up on top that was going to display the score of each player, and then it was also going to show who won. We also got rid of that, and we decided to make it a little bit more functional by realizing that we weren't using half of our LCDs. So now each of the rows, the back rows, is in control of the scoring points. So anyway, we'll show them some code. Okay. So code is already up.
So we broke the code up into different sections to control each of the different pieces. We had our buttons controlled with our EXTIs. So as you can see here, we started out with just an initialization, which sets up each of our buttons. We have a data pin connected to the buttons, and then we also have a ground connected to the button. So then when the button is pressed, it reads as ground, and that's how we set up our buttons. This is that specific edge cases, and this is just enabling our interrupts. And then for most of our interrupts, all we do is once the button is pressed, we tell the code to run our paddle control function, and we pass in whether we want it to do an up or a down movement. And as soon as we pass in that up or down movement in our lcd.c file, we have the logic of our up and down movement, which moves an underscore across a string of characters that's printed to the screen every time the paddle gets moved. And we used, this is just our initialization for the LCD. We pass in a couple commands that really sets up our LCD modules, and so after they're set up, we pass in that initial display to get the paddle ready for the player to use, and then we also have a C file for our LED matrix. Before I explain that, let's jump over to SPI, because SPI is really used for our LED matrix. We set up SPI to be we set up the correct clock polarity and the correct clock phase. The data is registered on the first rising edge, and the clock is active low or polarity low. We also set up our SPI to send out 16 bits of information, because that's how much the LED modules are expecting. And that is basically the control for the MOSI. and that also takes care of the clock signal sent to the LED matrix. And the other piece that we use for SPI is the select pin. The select pin is handled within our matrix print function. So this function takes in a full array of information that's needed to populate the LED matrix, and before it sends the data, it gets ready the select pin, and after the data is sent, it triggers the select pin high, so then the data is latched into the modules. And then we used a little bit of ball movement here on our LED matrix. We kind of just check edge cases. If it's on the edge case, it's going to change the direction. The ball starts in the top left of our LED array, and after it starts there, we set our directions to be moving in the right direction and down across our array. And so after our our movement function checks if the ball is in one of those edge cases, it makes the movements and then prints that updated LED array to our LED matrix.
Just want to check the time real quick.
Yeah.
Just want to make sure we're doing pretty good. Okay. So the other functions we use a pin setup in order just to set up our pins to be either output. Kind of gets away from just by calling a function. You can set things up exactly how you'd like instead of having to do a bunch of logic over and over again. That's just more of like a tool that we used, and we also use a timing. Anyway, let's do a demonstration of it. So here's our pin. We're using our camera. So as you can see, here's the LED matrix, the two LCDs, as well as our thing. So we can start it off, and as you can just press these buttons to move it from side to side. And so I just scored a point. I'll just make sure. No, I missed it. It's probably a lot easier to tell from this up view. I just want to check the time, make sure we're still doing okay. All right, we'll do this for about another minute. Hopefully I can bounce the ball. This game isn't as easy as it looks. Dang it.
We could have increased the speed, but it makes it much harder to actually play the game.
It pretty much makes it impossible to play the game. Just as is, we're having a hard time. It helps if you can kind of like track the ball and kind of see where it's going to go. Dang it. It's just went over. Am I about to score? 1, 2, 3, 4, 5, 6. Okay, that's good. And bam! As you can see, I've won the game. Anyway, thank you for watching, and have a good one.